Let's start with the first example. I have 3 raised to the negative 1/2 log base 3 of 9. So I'm going to first evaluate log base 3 of 9. So the way I should think about this is, let's say this is equal to x. 3 to the x is equal to 9. What exponent will this be? Well, clearly this has to be 2. So log base 3 of 9 is going to be replaced with 2. And then I'm going to multiply, okay, negative 1/2 times 2 will be negative 1. So this is the same thing as 1/3. Okay, so that's the final answer. The next one we have 2 raised to 2 minus log base 2 of 5. We want to go back to some of the properties of exponents. So if I have a and then let's say x minus y, I can break these up as a times x, a to the x times a to the negative y. So that would be 2 squared times 2 to the negative log base 2 of 5. Okay, 2 squared is 4. This negative, you can think of that as the exponent of 5. Okay, so if I have log of, let's say, x to the n, that's the same thing as bringing the exponent outside. Okay. So I can rewrite this as log base 2 of 5 to the negative 1 power. Another property we should know is that if I have, let's say, a to the log base a of x, this has to equal x. And the idea is that you're composing 2 inverses of each other. So you have like a x or exponential composed with a log, this, you'll always get whatever is the exponent, let's say x in this case. And because really this is what's happening. All right. So you always get what's over here. So in this case, that would just be 5 to the negative 1 power, which is 4 over 5. Okay, next one. Log base, or log m plus log n are the exponents, and the base here is 10. Because I didn't write what the base is for the logs, we're assumed to have log base 10. Whenever you add logs with the same base, you multiply what's inside. In this case, we'll multiply the m and n. Okay. Because the log has base 10 and this is 10, so those agree, we can cancel those out and get mn as our final answer. This next problem is very interesting. So I have 2 raised to the log base 2 root 2 of 15. Okay, so this problem looks very difficult. Okay, so the first rule or property we're going to use is a change of base formula. Okay, so let's say if I'm given log base a of b, I can rewrite this with a new base. We'll call it c, and that'll be of b divided by log base c of a. Okay, so those two are equivalent. The base I'm going to choose will be 2, and the reason is because that one is 2 as well. I'm hoping to get a situation where it's like 2 log 2 of x, and okay, and I'll get a final answer of x. So let's see if we're lucky. All right, so let's apply this change of base formula. So at this point, it looks pretty complicated and doesn't seem like we're getting anywhere. So let's see if we can simplify now. Log base 2 of 15, it's not much you can do there. But the log base 2 of 2 root 2, we can split it up into 2 logs. Because remember, whenever we have the same base and we add the logs, we multiply what's inside the log. And then from here, we can simplify further. We're going to leave the log base 2 of 15 alone. Log base 2 of 2 is just 1. Log base 2 of root 2, well, if you really want, you can think of that as log base 2 of 2 to the 1/2. The 1/2 comes out in front. We have log base 2 of 2, so that would just be 1/2. Okay, so that's 2 to the log base 2 of 15. 1 plus 1/2 is 3/2. Okay, I don't like this 3/2 in the denominator, so I'm going to move it to the top as 2/3. Okay. And this 2/3 can be moved to the exponent of 15. Right? So we're applying the property. So that turns into 2 to the log base 2 of 15 raised to 2/3 power. And what do you know? We have 2 and 2 here, so that's going to cancel, and we're going to be left with 15 raised to 2/3 power. I can think of this as 15 squared raised to the 1/3, and then 15 squared is 225. 1/3 is a cube root. So the final answer is a cube root of 225.